Hi, this is Mr. McGovern, and this is the first video in the Balanced Forces series where we look at what are forces. Now I have to lead in by saying that forces are a topic that students find very difficult to master. You might think you understand it because there's very few moving parts, but students mix up forces with movement, they mix up forces with energy, they mix up forces with momentum. And it does take a long time for forces to really be mastered. So make sure you pay attention, follow along carefully, and follow all the rules when you do your own force diagrams. Okay, so a definition you might have used in the past was a force as a push or a pull. So here we have a cat sitting on a box. The downwards force is the force of gravity, and the upwards force you might call the support force. Are each of these a push or a pull? Well, gravity we know kind of is pulling down, but is the box really pushing you up? I feel like the box is just there and the cat's not being pushed up with it. You could argue that yes, it's counteracting against gravity, but then you could argue that it's not really pushing in this case. So for that reason, I don't really like it. I like a more specific definition, not a push or a pull. And the definition I like is that force is an interaction between two objects. So in the case of gravity force, it's the interaction between the earth, which is pulling it down, and the cat. And in terms of the box, the support force, it's an interaction between the box and the cat. So we're really going to come back to these keywords interaction and between two objects quite a bit as we move through this topic of forces. So the types of forces you meet this year can be divided into contact forces, forces where there's touch involved, and non-contact forces, forces that can almost like magic, can interact between two objects and they don't even have to touch each other. So gravity is an example of that. So let's go through these one at a time. So the normal force is a perpendicular force between two surfaces. Perpendicular means 90 degrees. And normal, in science, normal means perpendicular. So that's why I call it the normal force. It's always perpendicular. You may have called it in the past the support force or the reaction force. So here I have a box, and if I'm thinking about that normal force, it's perpendicular, 90 degrees to the surface, which is straight up. I like the word normal because if the box is on a sloped hill, instead of using the term support force, if you're using the term normal force, then you really are thinking of that force at 90 degrees to the surface. A tension force is a pulling force, so you see it with strings and ropes and chains. So we have a man pulling the box, and so there's the tension force along the direction of the rope there. Friction force is another contact force that happens parallel to two surfaces. So the normal force happens perpendicular, 90 degrees. Friction force only ever happens parallel to the surfaces. And friction acts against motion. Traction, which you see is the next one, is something that assists motion. They're actually both the same thing, but one acts against the motion and one assists it. So, for example, we've got the person walking. The friction of the ground, you can see the arrow going parallel to the surface because that's what friction does. We'll also consider air resistance a friction force, but often the good thing in physics is that the air resistance is so small we can often ignore it, and in many questions they'll say, look, ignore air resistance. Traction force, remember I said it's just another type of friction. It assists the motion. So here we have the same situation. We said friction was going parallel but backwards for the box. The reason the person can move forward is because they have traction with the ground. If they were trying to walk on ice, they would not be able to move at all. So it is friction force that allows the person to move, and we'll go a bit more into that when we go into some forces down the bottom. All right, non-contact forces don't need to be touching. So the box is touching the earth, but even if I held the box above the ground, we'd still have a gravity force from the earth on that box. Electromagnetic force is a force we're not going to get into in this topic, but we will get into it when we do the electricity external, so there'll be a video on that. There are some more contact forces. So thrust force, buoyancy force, and lift force. And I really want to stress that these forces hardly ever appear. And thrust force is one that most people want to add to any moving objects, but it's not the case. Thrust force in physics has a specific definition. And the definition is it's a reaction to gas or some sort of fluid being pushed backwards. So with a rocket, when a rocket wants to accelerate, it ignites gas, and that gas comes out the back of the rocket, and that pushes the rocket forward. That is thrust. A propeller, when it spins, pushes air backwards, and that air pushes the propeller forward. That is thrust. A car driving along the ground does not have thrust. Okay, it is not pushing air backwards and allow it to go forwards. A person running does not have thrust. They do not push air backwards that allows them to go forwards. Thrust is only used for rockets or propellers. So here we have thrust from the air on the rocket. A buoyancy force, again, is not won't come up often at all in high school, at least in New Zealand anyway. We don't have it in the curriculum. It's a force that helps things to float, or if they're underwater or in any fluid, it's an upwards force. So here's my boat floating, and it's the buoyancy force that allows it to float. A lift force it's similar to a thrust force, but we're directing air downwards. So we push air downwards, a wing pushes air downwards, and it lifts the plane upwards. So that's how a plane is able to fly. So again, those more contact forces, thrust, buoyancy, and lift, you might see them occasionally, but only ever use lift for planes, only ever use buoyancy for maybe hot air balloons or boats, and only ever use thrust for planes and anything with a propeller or a rocket. Don't use thrust for cars. So if a car is accelerating, there's no engine force. That's not one of our ones we talk about. There's no push force, there's no forwards force. All these ones that you may have wanted to give to the car, acceleration force, especially not even a thrust force either. The reason a car can accelerate is because it has traction between the ground and the car. Remember, our definition of a force is an interaction between two objects, and traction really talks about that interaction. It says the only reason I move forward is because I'm gripping the ground with the tyres. So I really want to move, when we're moving forward, is to only use this definition, that the forces are an interaction between two objects. Our contact forces being those for normal, tension, friction, traction. Our non-contacts, mainly in this topic, being gravity. And every so often you'll meet some other contact forces, which are thrust, buoyancy, and lift, but you won't meet them often. And thrust force is something that you students, I know, try and give so many objects, but it is just not true. Okay, so we're going to see a lot more examples in the videos coming up, and hopefully it'll make a lot more sense when you see these examples.